All right, let's take a look at number 12 in section 6.1. It's kind of challenging to set this one up. The actual integration is not too bad, and then the final answer, at least the one they want and achieve, is a little bit tricky. So let's talk about it. We're going to find the area of the region enclosed by the graphs of y equal cosine of x, y equal cosine of 13x, x equals 0, and x equal pi over 7. Again, these numbers might be, or these functions might be slightly different for your problem. So part of the trick is, finding when you're integrating a region. This is actually a one region bounded by these four curves, and it's vertically simple, which means any vertical line drawn will have the same top function and the same bottom function so that you can set the integral up right. You actually graph them carefully on your calculator, say, and you have to set us up good. From x equals 0 to x equal pi divided by 7. That's a little more than 3/7. Okay, so it's going to be slightly less than a half, 0.5. But if you actually enter in your calculator pi divided by 7 for your x max in your viewing window, you will be able to see, of course, between -1 and 1 for the cosine functions. You'll see the graph of the cosine function barely, moving down. Remember, it continues to go. At 0, it's 1, and then it's equal to 0 at pi over 2. And pi over 2 is like a little more, 1.57 pi over 2. So, it's going to be way over here where it's going to be 0. But the graph of cosine of 13x, its period is much smaller, so it's higher frequency, right? So it's going to go through one complete cycle much rapidly than cosine of x does. In fact, it almost completes a complete cycle by the time you get to pi over 7. And it looks like they intersect at that same point. In fact, if you plug in pi over 7 for x in both of these functions, it looks like the y value is the same. But how do we know for sure? It's exactly the same. So I had to do a little bit of I did a little side problem on this from our trigonometry. When are these two functions the same? When will they intersect when their y values are the same? Well, solve this equation. So how do we solve this equation? Well, this is the way I thought to do it. These things being equal mean their difference is 0, right? If I subtract cosine of x from both sides. And now what I want to do is transform this difference into a product. And the way I'm going to do that is from sort of the somewhat obscure, if you remember from trigonometry, the sum to product formulas for sines and cosines. And you may or may not remember this from trigonometry. It's kind of like all those formulas that you have, the double angle formula, the sum formulas, double angle formulas, half angle formulas, and so on, all those things. And you finally get to the product to sum and sum to product formulas. Okay. So at any rate, this is the one for the difference of two cosines. Cosine of alpha minus cosine of beta is -2 sine of alpha plus beta over 2 times sine of alpha minus beta over 2. Okay, so I'm not going to derive that formula. You can go back to your trigonometry class to review that. But if I replace alpha here with 13x and beta with x, I'm going to get the following for cosine of 13x minus cosine of x. It's -2, right? Sine of alpha plus beta is 13x plus x over 2. Sine of alpha minus beta, 13x minus x over 2. Simplify, 13x plus x is 14x divided by 2 is 7x. Here I get 12x divided by x is 6x. So now I have a product of two. Well, -2 can't be 0, but one of these two things has to be 0. If I have a product of two or more values that is equal to 0, I know that at least one of the values must be 0. So if sine of 7x is 0, remember, sine is 0 at what? When the input is 0 or pi or 2 pi or -pi or 3 pi, right? And so on. So any multiple, n is any integer multiple of pi. So if I divide by 7, x is n pi over 7. So when n is 1, I get pi over 7. N is 2, I get 2 pi over 7. N is 3 is 3 pi over 7, so on. So this equation will be true for all these infinite values. I'm just looking at the positive ones. We could also look at negative. Of course, 0, if I plug in n equals 0, x equals 0 would be a solution as well. And then also sine of 6x could be 0, which means that x is n pi over 6. So n would be pi over 6, 2 pi over 6 or pi over 3, 3 pi over 6 or pi over 2, and so on. But of all these are all the positive values, by the way. So x equals 0 is also a value. And the smallest one of all these is pi over 7, which is, notice that if you remember, that's the sort of our right limit for the area we're talking about. X equals pi over 7. So pi over 7 is less than pi over 6. And so one other thing about the graph, so we know that's the point of intersection. And one more thing about the graph of the cosine of 13x. The period for this, remember the period is 2 pi normally, but since it's 13x, it's 2 pi divided by 13, if you remember that. And so we'll go through one complete cycle. We start at 0 or 1. We go through one complete cycle. We're back to 1 at 2 pi over 13, right? And then the function starts at 0, starts at 1 when x is 0, goes down to 0 at this point, to -1, back to 0, and then back to 1. What are these points? Well, they're evenly spaced. So if I take 1/4 of that period, I get 2 pi over, well, 1/4 times 2 is 1 over 2 times 13. So pi over 26, right? So, so in other words, we're going to, well, y equals 0, not at all these values. Sorry, that's not correct. But these are sort of the important points for the graph. At 0, we're 1. At pi over 26, we're 0. At 2 pi over 26, or pi over 13, we're -1. At 3 pi over 26, we're back to 0. And then at 4 pi over 26, which, by the way, is the same as 2 pi over 13, we're back to 1. So those are the values. So in other words, the zeros are at pi over 26 and 3 pi over 26. So that's, going back to my graph then, putting that all into play. Here's the graph of almost one complete cycle of the cosine of 3 pi over 6. And then they intersect right here at pi over 7. After pi over 7, then the cosine of 13x will be slightly above the cosine function. Bottom line is we're finding the area trapped between these two curves from x equals 0 to x equal pi over 7. So the calculus part is actually quite simple. That's a lot of analysis we did to come up with that. But from that, you should have the following integral. From 0 to pi over 7, the top function is the cosine of x. The bottom function is cosine of 13x. So it's top minus bottom, right? This region is vertically simple. Any vertical line will have the same top function, the blue curve, the cosine function, and the same bottom function, the red curve, cosine of 13x. Okay? So now the calculus comes in. We find this antiderivative and evaluate it at the upper limit and lower limit. So fundamental theorem of calculus, part 1, antiderivative cosine x is sine of x. Here we got a little chain rule, but essentially the antiderivative cosine of 13x is sine of 13x times 1/13. Why is that? Well, when I take the derivative by the chain rule, right, the derivative, the outer function will be cosine of 13x times the derivative of the inner function, 13. So this 1/13 will multiply that 13, give me a coefficient of 1 here, or -1. So that's just a simple u substitution. If you let u be 13x, you can derive this antiderivative. So be careful about that. All right, now comes the fun part. If you didn't think we had enough fun already, plug in x equal pi 7. So I get sine of pi 7ths minus 1/13 sine of 13 times pi 7ths is 13 pi over 7. So here's the evaluation at the upper limit. Well, if I plug in 0, thank goodness, sine of 0, I get sine of 0 here as well, is equal to 0. So I get 0 minus 0, I get 0. Now, this would be, really the exact value of this integral. But I saw an interesting answer in Achieve, so I want to talk about how to get that. This is not a common angle like, special angle, I guess, pi over 4, pi over 3, pi over 6, 2 pi over 3, etc., where we can use the unit circle to find the value of the sine. Here, I don't know right off the top of my head what sine of pi over 6 is. I can use a calculator to approximate all this, but they want the exact answer, symbolic and in fraction form, and simplified too. So 2 notes. Number 1, Sine of 13 pi over 7. Well, that's the same as the sine of 13 pi over 7 plus or minus any multiple of 2 pi. Remember, that's the period, the sine function. If I add or subtract 2 pi to the input, I'm going to be right back where I was, right? So the sine function just continues going up and down between 1 and -1, and we go through one complete cycle in 2 pi, right? 2 times pi, or about 6.28. So if I subtract 2 pi, which is what, in terms of sevenths, 14 pi over 7? 14 pi over 7 is 2 pi, right? 13 pi over 7 minus 14 pi over 7 is -1 pi over 7. Okay, so sine of 13 pi over 7 can be replaced with sine of -pi over 7. But also, sine is an odd function. So sine of -pi over 7 is -1 times sine of +pi over 7. Right? That's because it's a negative function. It's an odd function, so rather. And so sine of 13 pi over 7 is equal to this, and this is equal to this. So sine of 13 pi over 7 is negative sine of pi over 7. And if I replace that with negative sine of pi over 7, clean this up, negative times negative, positive 1/13 sine of pi over 7. Well, 1 sine of pi over 7 plus 1/13 sine of pi over 7 is a total of 4. Oops, that's not right. 14. I can't add 14 thirteenths, right? So this is coefficient is 1. Coefficient here is 1/13. So this would be 13 thirteenths plus 1/13, which is, as I've correctly written now, 14 thirteenths. Sorry, I had that wrong. So this is actually the answer that they're showing. I'm not sure if they would accept this as the answer. I would probably be okay with at that point on a test. But this is what they have. So it's kind of weird how they use these facts to simplify it. It is much nicer looking, though, than what we have. You can use your calculator and confirm that these two expressions are equal by approximating them. Okay, so this one's kind of long and dragged out, but I wanted to talk about this one. Not too bad as far as the calculus goes, right? Just taking the antiderivative and evaluating it, but it's more about setting the problem up. Always have a graph for these functions, of the functions that you're talking about, to clearly see what the region is, region or regions, if there's more than one, so that you can set up the integral or the integrals needed to find the area very carefully, finding the top function minus the bottom function, for instance. Okay, that's enough on this one. Hopefully that is helpful. If not, please ask for help.